So first of all, once again, the projection of u in the direction of v, we have a formula for that. The denominator is the magnitude of v squared, and so you do all that times v. So let's find the dot product. Multiply the horizontal, multiply the vertical, you get -2. Then we need the magnitude of v squared. So we'll do a squared and b squared, but we won't square root it. 25 and 9 is 34. So it works out to -2 over 34 times v, or -1/17 times v, where v is this. And it turns out you get 3/17, comma, -5/17 for the component, or the projection of u onto v, or the component that goes in the same direction, or is parallel to v. And by the way, the fact that, if you look at this, I'm saying in the same direction, but really it's not. It's an opposite direction, because this one goes left and up, this one goes right and down. So let me make a quick sketch. U goes right, something like this, 4 and 2. And apparently the angle between them is an obtuse angle. I say it that way because this is U and this is V. The projection of U that's in the same, or that's parallel to V, will be that. And then we're about to find U2. Okay? But like I said, it wasn't in the same direction. It was actually opposite direction, but it's still parallel. And then, once again, to find U2, you just subtract the first component from U. So U is 4.2 minus, someone get the door, please. He's just rude. You have to excuse him. Now, when you go to do the subtraction, I'm just going to work it as mixed numbers. You have 4, take away 3/17, you get 3, and how many 17ths? Oh. If you add back the 3, you have 17/17ths, right? And then the vertical part's easy because it's minus and negative becomes positive, so plus 5/17 is just that. Now, if you read the directions, it says find the projection, which we did, of U onto V. That's the first answer. And then once again, the second part, you're supposed to express U as the sum of those two components. The first one, that was parallel, plus the second one that we just found, that is orthogonal. Now, you could express it like they did, as just keep everything in fractions. So like 2 over 17, I mean, no, 2 is equal to 34 over 17. And so, and 4 is equal to, what, 68 over 17? That's what they did. They got everything to be fractions and then did the work that way. Same difference. And check your work, once again, these should add up to equal U, which was the 4, 2. And so you can check that. You should check, make sure the first one's parallel. That's easy. What's the slope of V? -5/3, right? The slope here is -5/3. Well, obviously this also works out to -5/3 for the slope. Now this is supposed to be orthogonal, so it's supposed to be opposite reciprocal, so it should be positive 3/5. That's less obvious. I'm not going to bother trying to check it. All right, moving on. Totally different kind of problem now. This is on, the notes you just picked up today, obviously. All right, let me draw this picture. So draw your picture separate. So you have your slope going at a 60-degree angle. You have this weight pulling down, and of course the weight is straight down, and it's 10,000 pounds. So here's the deal. You need to break this up, and get the picture is the trick here. You want to express this or break it up into a component that goes parallel to the slope and a component that goes orthogonal to the slope. What we really care about is the part that's parallel, because the point is, you know, if there's nothing there, then that much force is pushing the boulder down the mountain. The orthogonal part we don't care about, because that's what's pushing into the mountain, and the mountain will resist that. So we need to find this. That's our goal, okay? Now, first of all, you have multiple right triangles here. If this whole thing is a right triangle, which it is because this is straight down, then this must be 30, right? But then we're going to focus on this right triangle. This is easy. Just get the picture right. Now, if I want to find this, and we know the hypotenuse to be 10,000, will I do 10,000 times cosine of 30 or 10,000 times sine of 30? Since I'm trying to find the adjacent, cosine. And once again, you're supposed to know, going all the way back to geometry, cosine is opposite of hypotenuse. So that means the, no, it's not. Thank you. But that means to find the adjacent, you do the hypotenuse times cosine of theta. Or if we're on the unit circle, then we say cosine is x over r, which means if you want to find x, you do r times cosine of theta. Or if we're talking about vectors, then cosine is adjacent over the magnitude, which means the adjacent, not the adjacent, but the, well, it's adjacent in this case, actually. But normally that would be the horizontal component. So I'm saying it's the same idea. Type it in, tell me what you get. It should be, yeah, get a calculator if you don't already have one. You'll need one. Should get 8660. Okay? Try the next one. If you haven't tried this, then just write. Wait. Why are you putting it back? So why are you putting it back? Oh, I don't know. Give it to me so I can fix the battery. Come on. Like people who put dried up markers back in the bin. All right. Like I said, try this one. The last one, if you didn't already write it down, the answer is 8660.3 pounds. Well, like I said, go ahead and move on to the next one. And you should get 1294.1 pounds. I like the way they drew this picture. Is, you know, the last one, I'll come back to this. Last one, we kind of drew the picture so everything fits together. I'm telling you, you have two right triangles, but they represent different things. I mean, one of them is really just an angle. It's a slope, right? Whereas the other one is our force. And you can move that force wherever you want. I'm saying this force picture could have been farther up the hill, farther down the hill. It doesn't matter. It's not like it had to touch and form a right triangle, is what I'm saying. But same idea. If this is 15 degrees, and this has to be 75, because you do have a right triangle there. And then do the same thing. By the way, just for the record, our answer is the amount of force you'd have to use, but your force would actually be facing uphill, right? That's the point. is you use this amount of force pushing that way to keep it from rolling. That would be the actual, well, the actual force, the actual vector. All right, on to work now. And so listen, this is the main thing. Work is the force in the direction of motion times the distance traveled. It's those two numbers, okay? And so here's another way of expressing it. The projection of the force onto the displacement is what I'm looking for. But just for the record, displacement is a vector, and the magnitude of displacement is the distance, right? So here, we'll go and do one of this example first, using dot product, and then I'm going to explain it kind of using, well, just the picture. So the thing is, if you want to use the dot product formula, then you have to have your vectors both in component form. So that's what I'm going to do first. And it's, to get component form, you do the magnitude times cosine of the angle for the horizontal, the magnitude times sine of the angle for the vertical. And frankly, I'm just going to leave it like that. And the other vector is the displacement. Well, it's horizontal. It's 12 meters to the east, so it's 12 horizontal, positive 12 for the horizontal, 0 for the vertical. And then you do the dot product. So we're dotting our two vectors together. And to do that, you do the horizontal times the horizontal plus vertical times vertical. So here's the deal. If it's a picture like this, where the vertical is 0, then that part's just going to go away, and you'll simply get this. Okay? Type that in, tell me what you get. That is correct. Okay. Just dying like flies here. Now, we need to get the units right. Just for the record, up here, the force was in newtons. So like this was that number of newtons in the horizontal direction. Then the distance is in meters, so it's that many newton meters. But a newton meter is also known as a joule. And that's what it asks for. Find the work done in joules. And multiply by 12. Yeah, so that's it. And this part, once again, we didn't bother with because it was 0 anyway. Now I'm going to do the same thing, except for now I'm going to do it by hand. Look at this. I said you really just need the part of the force that's in the direction of the motion. That's this. Well, just like before, if this is your hypotenuse and you want adjacent to the angle, you do cosine. So the work will be the magnitude times cosine of the angle times the distance traveled. Well, that was just 12, wasn't it? So like I said, just figure out how much of the force is in the direction of motion, multiply it times the amount of the distance traveled, you'll have the answer, which isn't exactly what we did using the dot product. So you get the same answer, 339.4 newtons times meters, or joules. So that's what I'm saying. And listen, if this had been going at an angle instead of being horizontal, you could really do the same thing. Just if I rotate this picture, I would still do the magnitude times cosine to find the part of the force that's in the direction of motion, and the motion wouldn't be horizontal anymore, but it'd still be 12 if I rotate it, right? So I'm saying that's all you need to do for these work problems. So here, try this one. And just do it like I showed you on the last one. And you should get 207.8 joules. And by the way, I use the 30. If I'd used the negative 30 instead, would that have changed the answer? No, because cosine of negative 30 and cosine of 30 are the same. Because why? What do we call functions like that? Yeah, cosine is an even function. And so in this case, it wouldn't have mattered which one you used. All right, one more. I'll give you time to just read the problem. All right, so listen. As far as orienting the problem, it is convenient to make one of your vectors go due east. Okay, so you can express all your answers in relation to that. And so they did this for us, but I'm saying that's just, if they had it going like this way and the wagon's sitting here, then it's easier just to think of it this way, as like this being your positive x-axis, and just express everything like that. All right, what I want you to do is draw a parallelogram. We've done this before, actually. And then the 20 goes there. And we're trying to find this vector going across that way. Except for, I missed. There. I'll make it easy on myself. Okay? I'll call that B. Now, it'd be helpful if we knew this angle here. What's that angle? Yeah. Yeah, 152. You can do it the way, a couple ways. Double 28, subtract from 360, then split it in half. Or just subtract from 180. Either way. All right, now, so we do log cosines. So b squared equals adjacent squared plus adjacent squared minus 2 times adjacent times cosine of the included angle, which is the 152. Type that in. Pounds of force. Which, by the way, just a reminder, the missing side, since the two sides we knew were 20 and 30, the missing side had to be somewhere between the sum and difference. So it had to be between 10 and 50, so this fits. All right, so now I also want to know the direction. I want to find this angle first, right here. Okay? So we do log cosines again, the other version now. So cosine of theta equals, and this version you do the adjacent squared plus adjacent squared, so the 30 squared plus the 48.6 squared minus the opposite side squared over 2 times adjacent times adjacent. And when you go to type this one in, make sure you're very careful with parentheses. So once again, when you go to type this in, hold on, put parentheses around the whole numerator, parentheses around the whole denominator. Use second answer, so you don't get a rounding error, and then inverse cosine will give you the angle. So 11.1 degrees is not our answer, though. But so this is 11.1 here. That's fine. But that's the direction that they're pulling in. The resultant force between these two together is 48.6 pounds force in that direction. We're trying to find this force going in the exact opposite direction, right? And so we need to know this angle. Well, let's think of the third quadrant angle. So here's our answer, 48.6 pounds force. In which direction? What would that angle be? Hmm? 191.1? Because if it's third quadrant, basically do the 180 plus the reference angle. So it's 11.1 degrees into the third quadrant. And so when you say that, we mean 191 degrees rotated from, this direction. So that's how we oriented the whole thing. think on that worksheet, the vector applications, it just asks for the magnitude, but you should be able to find the magnitude and direction. And make sure you answer the question. All right, look, when you take out the day 2 worksheet that you just picked up, and the first problem talks about Regina. I want to go over a couple of these. Here, this section here. The bottom 2 sections on this, they're, I'll say weird, because they don't have unique answers. I'm going to show you a couple ways to do this first one. And look, you're trying to find another vector, and I'll say it has components A and B, okay? And these 2 vectors are supposed to be orthogonal, which means their dot product should be 0. So I'm saying one way to set this up is just to do the dot product. You do horizontal times horizontal. You do vertical times vertical. And the dot product is supposed to be 0 because the orthogonal vectors have a 0 dot product. Okay, fine. Let me simplify this. So like I said, you don't get a unique answer. You get this kind of relates the horizontal and vertical here. Here, I'm going to solve for A. So move the B term over, becomes positive. Divide by -2, you get -4B. So what I'm saying then is that if you want to come up with other solutions, or not other solutions, pick a vertical component. If I try 1, then that means -4 is the horizontal. We go with it. If I try 2, I get -8, I'm pretty sure. And if I try 0, well, actually that won't work. Don't do 0. Because you get a 0 vector and that doesn't count. If I did -1, what goes here? -1 times -4 is 4, right? And you get all these possible solutions. If I did -5, I'd have 20 here, because -5 times -4 is 20. All right, now listen. I showed you this approach because we're going to need it on the other kind of problem. But frankly, in this kind of problem, it's a slow way to do it. What I would do really is just look at slopes. What's the slope of our original vector? Right? You do vertical over horizontal, you get a slope of 4. Which means if they're supposed to be orthogonal, these slopes should be opposite reciprocals. So the slopes down here should be -1/4. Well, if you do 1 and -4, or -1/4, either way it equals this. And if you double these numbers or triple them or whatever, you get another vector that has the same direction. So like I said, these are all possible answers. So all you have to do on these is come up with one answer. Now look, the next one, I'm just going to focus on slopes. The slope of the given is 5/3. So our slope of the new one needs to be the opposite reciprocal. So I don't know, maybe 5 comma -3. That's a good answer. Or if you prefer, do -5 comma +3, because either way it has a slope of -3/5. Or if you want to, double them, 10 comma -6, or triple them. There's all sorts of answers. Easy. Just when you're done, make sure your answer is orthogonal to the given vector. Now, I want to do one in the next section. Here, it gives you the answer, so you should set up your formula. And what I mean is, first of all, we're trying to find U, which I'm going to say has components A and B. So once again, you do your dot product formula. The horizontal of the 2 vectors, then the product plus the product of the vertical should equal the 33 they give us. Let me simplify this. Now, by the way, it doesn't matter, but if you want to, I'm going to solve for a variable. It'd be nice if I didn't have fractions involved. So, Michael, if I want to make it so I don't have fractions after rearrange, should I move B across or should I move A across? Say again? Good. And like I said, it doesn't matter. It'll work out the same either way in terms of final answers. But you see now, if you move B across and you divide by the smaller number, then you won't have a fraction. It would be okay. If you moved A across, divide, you get a 1/2 A. The way you do it. Now, this is just like the last one. Once you have this is not the answer. You're supposed to come up with a vector that has this dot product with U and with V. So if I try 1, I'm just picking numbers. If I put 1 for B, what do I get for A? Yeah. Or if I try 2, I get what? And you might notice a pattern at this point. The next one would be 2 more than that. Why is it 2 more? Because this is a linear function with a coefficient of 2. And so if I try 0, by the way, 0 would work here. I'd get 11. And these are all possible answers. There's an infinite number of answers. I wanted to show you that these really do work. Watch this. What should be true now is that if I did the dot product of either one of these options for u with v, I should get 33. So watch. If I do the dot product, I do horizontal times horizontal, that's vertical times vertical. And that's 33 plus 0, which sure enough is 33. The next one, I do horizontal times horizontal, the 3 times the 13 from this one. I do the negative 6 from here times the 1 from this one. Well, this time I get 39 here, I get negative 6 here. No, 33 for the dot product again. So I'm saying these are all viable answers. And there's a whole infinite list you can choose from. So pick one and write your answer, okay? What I want you to do right now, though, is go back and do the first problem in this worksheet. Regina? Do that one now. So here, all right, first of all, what they expect you to do on these, if you look at the solution manual, and I put the solutions to this unit on my website, they expect you to use the formula for the angle between 2 vectors. But if you want to find the dot product, we kind of need these in component form, which they kind of are, but I want to get this, evaluate these. What is cosine of pi over 3? Good. So u could be expressed as 1/2 I plus square root of 3 over 2 j. Then v, of course, is square root of 2 over 2 for both, but which one's negative? The horizontal, right? Because the second quadrant, cosine's negative. And then plus, positive, for the vertical. Now, one more thing. What is the magnitude of each of these? 1. You don't recognize it straight off the unit circle, right? And at this point, I'm going to abandon this way of doing it, because we could do this. You can find the dot product by multiplying horizontal times horizontal, vertical times vertical, punch it on the calculator, use the calculator, but there's a much faster and easier way. They wanted to know the angle between the vectors. Well, they kind of told you the direction both vectors are going, so just subtract those angles. So I'm going to do 3 pi over 4, the bigger one, minus the smaller one, and we'll have our answer directly. Here, that's 9/12. And this second one is 4/12. Triple the first one, top and bottom, quadruple the second one. You get a common denominator, so you get 5/12, which is exactly the answer that we would have gotten if we pursued the other way. If we found the dot product, set it up, type in the calculator, did an inverse cosine, we'd get 5/12, but it'd be a decimal. Okay? So like I said, these just do that. So like I said, this worksheet's due tomorrow.